In the last part of expanding universe, you see, we talk about that how the universe expansion will start like with a big bang, but now we are telling that how a formula that changed the speed of universe in the rate of universe. Okay, what I'm telling right now is that space expansion of space is have no rate, no speed. It's have a rate. It's have a frequency, and how I will tell you. Okay, so in the last video we talked that the the objects that are closer to us are expanding with a slow speed, and the objects that are far from us are expanding with a double speed. And how it's possible is by megaparsec and redshifts. If you understand both topics, I will guarantee you that you will understand the whole expansion of universe. How? I will tell you. Okay. So, this is the formula of a speed. How we can find any speed of any object, like light speed of light, okay? Like on an average, 3 lakh kilometer per second, okay? This is the speed of light. How we calculate? We measure a time gap between this point, like light is emitting from this point to this point in a particular time. We know the time, we know the distance, okay? Distance by time, okay? Distance upon time is equals to speed. But here's come the space expansion rate, not speed, not like kilometer per hour, miles per hour. Space is not expanding with the speed. Space is expanding with the rate, because here's come a megaparsec, the unit at which the space creates its wavelength. How? I tell it by the redshift. That how redshift works. Okay, you studied in your childhood that in every science book that everything reflects a wavelength. Like everything is the like thing. Uh, a leaf is a green color. A leaf looks like in a green color. Why? Because it's absorbing that kinds of wavelengths and reflecting the other wavelengths. That's why it's looking green. Okay, so like this one green, this green area is like leaf. The leaf is only absorbing all the colors in the spectrum, in the wavelength spectrums, and only emitting the green color. That's why the leaf looks green. Look, this shirt looks like blue because it's only absorbing the all the wavelengths and only reflecting the blue wavelength area. Okay, that's why it's look like blue. So this is the concept of wavelength. If you want to know about the wavelengths morely, I will tell you in the more specific video. Okay, so that's the concept of wavelength spectrum, in which a star, any galaxy emits a kind of a wavelength. Okay, emits a kind of a wavelength. Like a star, the earth emit a different kind of a wavelength. It's because it's absorb all the wavelengths and emits the wavelength that is not absorbed. Okay, so that's why the, like this galaxy, this earth is emit a different kind of spectrum in which this area is blank. That's how the earth looks like in green color on outer space. Like example, okay, for an example, okay, this area is green for this galaxy. If any alien are in this galaxy sees the earth from this distance, okay, from this distance, like this distance, they see the earth in a natural green color. Like they are emitting a green like colors of wavelength in this spectrum of wavelength. Okay, but if the galaxy is far more away from us, like this one is, it is a little gap but kind of like millions of years, millions of light years, then it seems like a yellow because the wavelength is travel through space with a frequency. It's stretching up the wavelength when it's emitted to earth. Is like the gaps between the wavelengths from this crust to this crust is this. Okay, and when it's going through the galaxy, this side, this is closer to earth, is emit a green wavelength for this galaxy. But the wavelength, the area between the gaps between the wavelengths from this crust to this crust increase by the distance. It's getting bigger from this thing to this thing. Okay, the wavelength is stretching out by what? By the distance that is traveling. Okay, from this one, this point, from this point. Okay, let's see, the wall is emitting some kind of wavelength to me. I see a wall white, but some kind of millions of light years okay, far from us sees this white ball in a different kind of a color because the wavelength are stretching from this area to this area. This is called the red shift. Okay, if this galaxy is not this far, it's become this far, then this red shift, this green color turns into the blue. That's why from the space the earth looks like mainly the blue. Okay, but it's an example, not take it seriously. Okay, so this is called the redshift. If we go far and far, we see the Earth in a red color. That's why the far distant stars and galaxies looks only in a yellow, in reddish forms because their wavelengths are stretched in this kind of thing that they are only emitting a red kind of a spots in this spectrum. Okay, that's why. And how is this possible? Okay, because the space is stretching out in a frequency rate. Okay, the far we are, the far the wavelength stretched, the far the expansion rate of the universe is going. That's why the galaxies that are far from us are stretching out in a very maximum way, and the galaxies are near to us are stretching out in a very small way. That's why their colors are changed. The far more galaxies have us very common colors. Okay, and the galaxies that are closer to us have a different kind of color combinations because of their wavelengths they are emitting. The space is stretching and the wavelengths are also stretching from them. But as a cosmic level, at a small level, at our level, like we as humans, atoms and matter, these not applicable because they are not applicable at a human level. Okay, for an example, at a human level. Okay, but they are applicable, they are seeing seamless, not like we are sitting here but don't see any stretching, don't see any wavelength change because the gaps between us and other matter and other atom are very very small. But at a galaxical level, at a cosmic level, these gaps are getting bigger and bigger and bigger. So my Bluetooth device batteries are just dead. Okay, so here's we can understand this. The megaparsec is like a particular unit at which the space is expanding from a particular distance. Like it's like 1 megaparsec is equals to some kind of a 70 and 80 million light years, like that, kilometers. I don't know. If you have Google, you can search it like this kind of thing, like this kind of thing. Okay, and you can see a limit at which 1 megaparsec equals to something kind of a distance. And if you put a megaparsec, the formula of megaparsec, in the speed formula at which you are saying that the space is expanding from a speed, if you put a megaparsec into speed formula, you find a unit like 1 by time, 1 by something time. Okay, that's kind of a frequency rate. Okay, you find a formula that says the universe is expanding from a frequency rate. Okay, from a wavelength stretching formula. Okay, so that's how the space is expanding.